So allow me to keep writing on the left side of the screen here, and we'll find out tension in the cable first in part B of the question. For that, I draw the free body diagram of this cart 1 in blue color, and as you can see, there is an applied force F horizontally to the right. And then if you look at this figure carefully, the same cable is running from this point and passing over the pulleys to be attached to this post here. So since the cable is assumed to be massless and the pulleys are assumed to be frictionless, the tension exerted by the cable remains the same in magnitude at every single point of this cable. And therefore, we have got a force of tension applied by the cable here to the left, and the cable also exerts the same force of tension at 2 points of this pulley A, at the topmost point and the lowermost point. But since this pulley A is connected to this cart 1, in effect, this cable is exerting the force of tension on cart 1 at 3 different points, this point, and this point. So for this cart 1 with the fixed pulley A attached to it, we have got the force of tension acting to the left at 3 different points. Understand this. And all these tensions have the same magnitude of T only, right? So we have got the applied force F to the right and the force of tension exerted by the cable to the left at 3 different points of this cart 1. Under these forces, the acceleration of cart 1, that is taken to be A1. So this was the FBD of this cart 1, and therefore the equation of motion for cart 1 will be, well, I have chosen the direction to be my x direction, therefore I might write down the equation of motion is sigma Fx. Applied force is F minus 3T is equal to mass of the cart, that is m1, into its acceleration a1. This is, well, let me call the previous equation, constant equation here as 1 for reference if any, and that is my equation number 2, equation of motion for cart 1. Similarly, I am going to draw the FBD for the cart 2, and this is the cart 2, and as you can see, the cable running over this pulley B is applying a tension force to the right at the topmost and bottommost point of this pulley B, but pulley B being attached to this cart 2, in effect this is also the force of tension exerted by the cable on the cart 2, and therefore I show here these two forces of tension acting on cart 2, and under these forces the acceleration of cart 2 is assumed to be A2, right? Vectorially, let me call these forces of tension as minus T each of them, because these tensions and these tensions have the same magnitude but opposite direction. So for cart 2, equation of motion becomes, well, in the x direction only to the right, twice T is equal to mass of cart 2 into its acceleration A2. That let me call equation number 3. Now we are supposed to find out the tension in the cable, and therefore since you already are aware of the value of M2 and A2 is also found out in part A, we can straight away from equation number 3 can write down the tension in the cable is given by M2 A2 by 2. That is, M2 is 10 kg, A2 was found to be 3.0 meter per second square divided by 2. This is giving me 15 Newton. This is the answer of part B of the question. We have completed part B here, and going for the part C, magnitude of the force applied, to find this F here, that is easy. Going back to equation number 2 and rearranging the terms, you can see the applied force F is coming out to be M1 A1 plus 3T. isn't it? Putting the values, M1 was known to be 15 kg, A1 was also given to be 2 meter per second square, plus the force of tension was just now found to be 15 Newton, and this is coming out to be 75 Newton. So this is the answer of part C of the question. Let's quickly look at the answers once again. We have got acceleration of cart 2 is 3 meter per second square. The tension in the cable is 15 Newton, and the applied force on cart 1 is 75 Newton. And here are the answers.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.